So I'd like to welcome Tim Liddiard. Tim became Countryside Ranger in 1996 and is now the Senior Natural Environment Officer for the Government of Jersey. Tim somehow manages to organise and run the entire habitat management programme in Jersey, as well as managing numerous other conservation projects, public access, and his involvement in developing policy and implementing legislation. And with all that, somehow he's found the time to talk to us on his comprehensive programme of habitat condition assessment to inform management and restoration. Thanks, Tim.
John, thank you very much for those kind words, and it's a pleasure to be here with you guys today. My name is Tim, and I work with the Government of Jersey Natural Environment Land Resource Management Team. And during this talk, I will be talking about how to assess habitat condition in order to ensure that the results feed back into the management cycle. Because of the size of the subject, sorry, there's a bit of a delay in slide. It is the down button, right?
Yeah, you're going to have to go. You need to click on the screen first to take control.
Yes, okay, thank you. Because of the size of the subjects, I'll be splitting this short talk into some bite-sized chunks, including why and when to carry out management. Of course, some questions do need to be answered before moving in to carry out any site work, especially if any big kit might be being used, tractors and that kind of thing. The land manager or the owner should know what it is exactly that they want and why. A major consideration is knowing when the point has been reached to know when improvement works are needed. And then the monitoring side of things, the desired state or the condition of habitats needs to be illustrated in terms of objectives, and then monitoring is carried out to assess whether these objectives are being met or not. An important part of the process is how the monitoring records or results feed back into the management. So once the information has been collected and collated, how does that inform practical management? And then lastly, moving with the times, I've included a couple of slides showing some of the options that are available to us and others in order to move in pace with technological advances. But before I go any further on that, just quickly, I'd like to illustrate a point. In Jersey in 2006, there was a fire which burnt in Bully Bay on the north coast. A total of 4 square kilometres were burnt of mainly gorse and heather dominated habitat, which was lost. Now, just a month later, it started to turn green. And it was at this stage that we received a number of reports about how well the area was recovering. Doesn't it look great? And isn't it recovering really quickly? Now, look a bit closer, and it's not the case. What you see is that bracken has become dominant, as it often does following a fire. This example shows a case of habitat change, because habitat change can either be very quick, which is in this case, or it can be very gradual and difficult to notice. Either way, an objective needs to be relied upon to remove any possibility of a general perception guiding the management and not the facts. So why and when carry out the management? And what are the intentions, and are they justified? You need to know when to intervene, and the monitoring process is a very efficient method to flag up the need for work while informing what work needs to be done in order to improve the condition. Setting the objectives can be difficult, and knowing which habitats should be encouraged on the site and which should be controlled. Site history is going to inform the land manager or owner of that land of the current habitat extents and how they were created in the first place. And you're able to build upon that, trying to recreate the processes that ended in what you have at that moment. And then the current features of importance, that's gained by monitoring also, and any obvious control needed to remove invasive non-native species and the like. Now, the process of monitoring, this is an aerial of Normal Common in the southwest of Jersey, and there are 108 monitoring quadrats on the common, and they're placed on monitoring transects. And each of the colour blocks that you can see on the map are classed as a specific habitat patch, and they're assessed independently of one another. So the yellow is dwarf shrub heath, the blue is coastal grassland. Depending on the habitat type, the majority of transects are based on a 2-metre radius from the survey point. The information collected can be downloaded onto app. We use Oryx Maps, which is a free app for Android. You can add the waypoints, the transects to the map, and then export to GIS and vice versa, which makes it a fairly flexible system to work with. Each of the pink points corresponds to a monitoring point with an associated unique number. At each monitoring point, the surveyor assesses that patch against the habitat objectives, which results in the point either receiving a pass or a fail. Now, the use of a tablet has replaced the need for carrying a bundle of A3 sheets across an exposed headland on a windy day, which was rather tricky. And even though you can't see it in detail, this is an example of a habitat survey recording sheet, which is used to assess the habitat against the objectives. How much heather do you want on site? How much gorse do you want on site? What mix of height and structure do you want to benefit species like the Dartford warbler, green lizards, field crickets, and many more? Now, the writing of the habitat objectives is arguably the toughest part of the process, and a number of test runs are needed to get the objectives close to providing what it is that you want on the ground. We've tried to make sure that habitat objectives can identify whether the key features of sites are still present or not. They've been designed to be repeatable so that changing condition of features can be identified over time. They also act as markers for interventions which are needed to direct change, for example, to remove invasive species, to introduce grazing, or to reduce the scrub at any point in time. It doesn't look it, but it is quite simple to use, and it doesn't require any expertise, and it doesn't require the use of any specialised equipment. So it shouldn't matter who carries out the assessments, as long as they have the basic sort of understanding and principles of ecology and can recognise gorse and heather, etc., then pretty much anyone can carry out this process and it shouldn't affect the results. Instead of carrying these bundles of A3 sheets around, we use an app. The surveyor can download an online app such as Survey 123, which locates the relevant monitoring point in the field, and then one is able to assess that point. The collected data is therefore live and will automatically be input into a single database for analysis at a later date, ready to inform future management tasks. This is a much cleaner and more efficient working method than being paper-based. It minimises double handling and the likelihood of mistakes. Now, the failed points can be shown on GIS. Each failed point is highlighted as a red dot, and the turquoise point corresponds to the row in the table which tells you exactly why that point failed and what should be done to achieve a pass. So, of course, this can be then prioritised and slotted straight into the annual work schedule. Going forward, habitat condition monitoring is very time-consuming, and to be honest, it can be quite dodgy, traversing steep coastal slopes above the cliffs and scree slopes. So what we're looking for is a greater use of automated software to capture the current extent of habitats and, importantly, the habitat change over time. Ultimately, we're looking to find that balance between automated methods and the collection of data by surveyors on the ground. Of course, using automated technology, it's very difficult to pick up the detail on the ground, for instance, the smaller floral species, etc. So we mustn't forget that you do need that human input. Also, currently, our habitat assessments are judged primarily on the condition of habitat, but we're looking to include selected representative species data from a range of taxa to make the process more robust, because the reality is that the habitat could be looking fine and the associated fauna should be there, but this doesn't, or this shouldn't be taken for granted, because there are, of course, many factors which may affect the possible presence of a species at any one time. Some options for moving forward include using Sentinel, which is very much in the realm of space age technology. Sentinel is an Earth observation mission from Copernicus satellite program that takes images at a high spatial resolution of between 10 to 60 meters and can be used. We're talking to Eurosites at the moment about best practice across Europe in this field. There's also Liddiard, which stands for light detection ranging, where a laser is rebounded from a plane or a helicopter as a platform, and it's very good for measuring habitat structure. It shows the height of habitats, so it can tell you if your gorse is 10 foot tall or if it's 1 foot tall. So that's very useful. And also the use of drones, of course. And here I have a couple of pictures. This first one is a photo, an aerial taken from a drone at 50 meters. And you can see quite a lot of detail there. You can see where the gorse is. You can tell where the small patch of heather is in the top right-hand corner. So you can pick up quite a bit of detail there. The second photo is from 20 meters, and you can, it's a bit fuzzy down the bottom, but in general, you can pick up quite a lot of data there. And lastly, this one is from 15 meters, and you can even pick up the individual brambles in the top there. So drone work is certainly a way to go. Saves people from traversing the coastal slopes, etc. And I would like to leave you with that. So thank you very much for listening today.
Thanks, Tim. That was fascinating. It's really good to see how you're getting on with that monitoring.